What's up? Today we're going to talk about regression with Excel using linear relationships as well as nonlinear, like exponentials. We'll also modify some data so it becomes linear and or transpose the data, not necessarily modify it. And then mention R squared and MAPE values again, similar to how when we talked about regression and measures of how well the goodness of fit with Python. And then we'll briefly touch on integrating numerically a curve using Excel. So with trend lines, regression with Excel is straightforward. You can use linear relationships and nonlinear, provided that it's a standard form like an exponential or polynomial, or we'll use a line in this case right here. Data plotted against X. I can first plot it and then right click and say add trend line. And that's performing a regression analysis. And the default is a linear relationship, and you can display the equation and the R squared value. And there it is. There's my slope and intercept. And I can increase that size so I can read it. And let's do one that's not linear. For instance, I have some bacteria, and in this case it's growing exponentially as it has sufficient nutrients. And I want to know what's the time constant for the exponential growth. And so I can plot that growth, and I've done so here. And then I can right click and add that exponential trend line right there and display the equation and also the R squared. And I can hardly see it, so I'm going to increase the size. And I don't like the grid lines behind this equation, so I'm going to fill that text, kind of that equation box. I double clicked on the area and then did a solid fill with white. And then I'm interested in that time constant, that tau value. Well, that's just 1 over this value, because my x in this case is t. And so I'll just type that in, equals 1 divided by 0.0587. 17 minutes for this E. coli growth rate. Another way to perform regressions is to transform the data. So sometimes you may have something like this, where you have a concentration versus time, and you'd like to fit it to a second order model. Here I've got that shown, and so how am I going to fit this? I don't have a 1 over c kind of a relationship or an inverse relationship on my trend line menu. I don't have that form. Well, one way to get around that is to linearize this. So if I were to linearize this, I could make this whole side one variable, and then I have y equals mx basically, because then I could fit a line to it. Let's see if that was going to work. So then we're going to say 1 over c minus 1 over c naught. And so I'm going to say equals 1 divided by concentration. There's my concentration. Minus 1 divided by my initial concentration. And that one right there is my initial. So I'm going to have to do my absolute reference. And then I'm going to drag this down here. And let's plot that. So, oh, wow, that looks pretty straight, like a line. So I could change my label here. It's no longer that, but 1 over c minus 1 over c naught. And we can fit now our trend line, use our regression in Excel, display our equation and our line, our squared value. And I don't see a lot of, so I'm going to increase the size of that guy so I can read it. And I don't see a lot of significant figures, so I'm going to modify that. I can double click on that. And I think, it's under this chart, and it's a number. And I'm going to change it from general to scientific and increase the number of decimal places. And there is my fit. So what do you think about that? I've got a slope. I want a slope to be 0 because I didn't want a slope over here. I've already got my slope somewhat built into how I did that. So I'm going to click right here and set my intercept at 0. Oh, great. There we go. And now my K value is just 9.756 e to the minus 6. That's my K right there, because I transposed the data, plotted this versus my time, this on the left versus my time. This, in a sense, this linearizes it. And I've got a slope. I found my K value. Another method, besides transforming your data, is with the solver and minimizing the sum of squared errors. So I've got here an Antoine equation for the acetone vapor pressure, and I've plotted the log of the vapor pressure versus temperature, and it has a nice curve there. And from previous experience, I know that this is the relationship that best describes the vapor pressure. So I've got A minus B over T plus C, and I've got these three constants, and I want to know what are those constants for my acetone, so I don't have to be right on a data point per se, but I can get a vapor pressure at 230, for instance, for my prediction. So we're going to fit our Antoine coefficients to minimize the difference of the error between my model and my data. So there's my model. I've typed it in right here. And I also transpose my data so it's a log of my actual vapor pressure. And then I'm going to just calculate my error here, which is the squared error, data minus my model, and I square it so that the negative values don't offset the positive values when I'm minimizing my error. I got to square that. I can copy that down, and then I just sum that error right there. And now I'm going to minimize that with my solver. I've set my objective as my sum of squared errors, and I'm going to change my constant values there and for my model and hit solve. And it solved it, and there's my A, B, and C. Let's see how good the fit is, because I don't have the model actually plotted on there. So I'm going to right click and say select data. I'm going to add a model and give it my X values of temperature and my Y values of my model, and plot it. And it didn't do a very good job of that. What did I do wrong? Select data, my model. So let's make sure I got my model values. Did it not? Okay. But they're points, so I don't want points. I want lines for my regression. So I'm going to take off my marker and turn on a line, and I'm going to make it dotted so I can see the data, and that looks really good. So there's a way to perform regression by minimizing the sum of squared errors in Excel. And likewise, you can calculate R-squared values with Excel using this R-squared function, RSQ. And you could also find the MAPE values, the mean absolute percent error. I like that a little better because it gives me an idea of what percent off am I. Sometimes the R-squared value is ethereal to me. And lastly, let's integrate numerically a curve in Excel. And I can do that by using the trapezoid rule. So I've plotted a curve, and now I'm going to find the area under that curve, and I've drawn some rectangles, kind of indicating a trapezoid. I didn't draw a trapezoid, but this height, I'm going to average the two heights. Imagine if it was sloped up here. I'm going to average those two heights so it isn't a rectangle at the average position of the height. And this rectangle is not exactly where I want it, but yeah, somewhere around there. And I'm going to sum up all the areas of these trapezoids that are right next, that are kind of follow this curve. So I'm going to do equals the base, which is the difference between my x values, x minus that, that's my basically my step size there, times my average of the heights. And that will give me an area for that particular rectangle or trapezoid. And then I want to add that to the previous area, so I can sum that up. Or maybe it's more clear if I just do that one area and then sum them. So then I can go equals sum of all of these individual areas. And my integral, that is the integral. I hope you liked the video and learned something. God lives and loves us.